appreciate you all being here. Thank you so much for coming. I know that on any given day you have a lot of places where you could be, but instead you chose to be here with me, and I am forever grateful for that. I am Josh Long. I work on the Spring team. These are my coordinates, and there's a few things on this slide that are worth your time. First and foremost is the Git repository at the very top there. That Git repository contains everything you're going to need to be able to follow along at your own leisure, at your own discretion later on at home. So find that code. It's for you, not for now, mind you, definitely not now. Not enough Wi-Fi to go around, and we have a lot of stuff to do. So grab that URL there. Note it for your own reference, for your own edification. Should you have questions, when you have questions, ineluctably, don't hesitate to reach out to me. My name is Josh Long. I'm at StarbucksMan on Twitter. My direct messages are wide open, so please say hi. Say hi. I'm happy to answer questions beyond our meager time here today. I work on the Spring team. They made a toy out of me in China. I thought that was kind of cool. I have a bunch of different videos on Safari that are out there on different topics that you might be interested in. I've got a book called Cloud Native Java, which is all about how to build applications that survive and thrive in the cloud. I've got a podcast every Friday. It's called The Beautiful Podcast. You can find that there. New episodes with all sorts of different cool people. Who do we have? We had Gene Kim on recently. We had Dr. Dave Sire. We have lots of people in the Java and the Spring ecosystems. I have a weekly blog called This Week in Spring. I've been doing that for 9+ years, every week since January 2011. I've got a screencast series called Spring Tips. Last night we just published a new episode on RSocket and security, so that's up yesterday. And of course I've got a new book on which I'm working called Reactive Spring, and Reactive Spring is really what we're going to talk about today, right? It's really a very abridged version of that book. And there's a lot of stuff that we could talk about, but we don't have a lot of time. So I am going to do my level-headed best to keep it succinct, to be brief. We have to, first of all, in order to be able to embark upon this journey together, we first need to contextualize why we're taking this journey. What are we trying to solve? What are we trying to do when we talk about reactive programming in Spring? Reactive programming is not a new solution. It's not a new solution, and the question that it responds to is an even older question, but it's still, I think, more appreciable, more important today than it has ever been. Today, we are building microservices, we're building cloud-native applications. We see a proliferation of clients, different kinds of devices, talking to our services, and these clients create more demand than we've ever seen before. And we've had a fairly pragmatic answer to this scale, to this demand, in the last 10+ years. The answer has been, hey, if you want to handle more users, then move to microservices. Get rid of the state in your web service, and that way it's cheap. It's embarrassingly parallel to be able to scale it out. We can just throw them behind a load balancer and have the load balancer do round-robin dispatch across a number of different nodes, and this works just fine. The only problem with this, however, is that it's not really a great solution. It's just a pragmatic one. It gets us across the finish line. It allows us to handle more users, more transactions, more demand at any given time for the same service. But it doesn't answer the original question, which is, why can't we handle more users with an existing node? Why can't we handle more capacity with one piece of software, right? So the question then is, what can we do to better that situation? And why are we constrained as we are right now? What is the bottleneck? For a lot of people, that bottleneck is actually input and output, right? Think about what happens when you build a microservice today. You talk to a database, you talk to JDBC, you call other web services using the REST template in Spring, right? You make all these calls over the wire, and as you make all these calls over the wire, what are you doing? You're reading input and sending output. And as you read input, you're typically using a Java I/O input stream. This has the side effect that in order for you to get the next byte across the wire, you need to wait for that byte, right? This gets us into a very treacherous territory. You see, we cannot afford to build software on the assumption that the internet, the network, is going to be infinitely fast, that that there is no downtime, that there are no service outages. That's a fool's errand. We call these, and many others, the follies of distributed computing, right? These are very, very problematic. So what we need to do is to write software that is aware of the fact that things are going to come asynchronously. It's aware of the fact that things are latent, that there might be a lot of it. And if this is the case, then we cannot afford to sit there waiting for the next byte. And the reason we can't afford to sit there waiting for the next byte is because two things. One, threads are very expensive on the JVM today. They're backed by an operating system thread, each one of which is very expensive. It carries about 1 megabyte of context that makes creating more threads very, very expensive. And two, assuming that we can just wait for the next byte and that it will be here is, asking for trouble. We're betting the whole farm on the idea that the next byte will be here, when we all know, having been in production for more than a minute, that things will fail. There will be service outages. Things are going to fall apart, and your job is to write software that responds to that tumultuousness, that volatility, as well as you can. So reactive programming gives us solutions for this, and that's what we're going to talk about today. The question then is, how do we address this? How do we not block that thread? How do we not sit there waiting for the next byte? What do we need to do to flip it around so that when we ask for data, we're given the data, but in the meantime, we're not waiting, we're not blocking a thread. Somebody else can reuse that thread, right? We have ways to do input and output that are asynchronous, right? In the JVM, there's been support for asynchronous I/O, for example, for a long time. Who knows how long? What version of Java introduced asynchronous I/O? Don't all raise your hands at once now. Yeah.
Is it Java 9 is where we got the final the reactive programming interfaces, right?
Right, but that's, so good answer, but not the right one. Sorry? 4, yes. 1.4 came out in 2002, in February of 2002. So we're about 18 years now. It's been 18 years and some change since we've had java.nio in the JDK. And remember, if it's in the JDK, that means it's well supported on a number of different host operating systems. It works natively on all the operating systems that Java targets. So that means that we were able to do asynchronous I/O on OS X, on Linux, even on Windows. Windows. Can you imagine? 18 years ago, you could do software on Windows. So this is an amazing thing, right? It's been in the JDK for a long time, and yet I don't imagine that most of you have written a lot of code using the NIO interfaces. I certainly haven't, and the reason is because it's a terrible API. I don't want to write code that low level. Most of us don't. There have been, in fact, in the intervening years, there have been another package, Java NIO 2, right? There's a whole other package, and then on top of that, we have things like Netty that all strive to make working in that low-level asynchronous fashion less painful, right? I'm not saying good, I'm just saying less painful. So the thing is, why don't we all write code in terms of that API? Part one, it's painful. And part two, we just haven't had to. For the longest time, most of us didn't have the scale that demanded that. And then once we did, we had solutions like horizontal scale out that gave us a pragmatic solution to limp across the finish line and into production. This has been a half step. But I think it's time to revisit that. I think it's time to revisit this asynchronous I/O. What does it give us? What can we do if we build our software on that paradigm, right? And remember, it is a paradigm shift. It is a major rethinking of the way we build systems. Instead of writing software that assumes that the next byte will be will be just around the corner, we now need to say, hey, I'm going to ask for data, and then I'm going to do something else. And when the data comes back, I'll get an interrupt or a callback. And it's in that callback that I can then actually start processing the data. So instead of having this very sort of this first, then that, and then this behavior, we are now having this sort of asynchronous callback-centric world. What we need is some way to describe that asynchronous flow control, that stream processing that's based on asynchronous callbacks. Lots of different languages have come up with solutions that kind of give you what we're trying to do here. We want composability when we do asynchronous processing. In other languages, you might have heard of promises, right? We had something called a completable future. We have it, and it's in the JDK. But the problem is that a completable future just gives you one asynchronous value. What about 2 or 5 or 10 or a billion or infinite values? There have been no good types to model that. So several years ago, several different organizations, Pivotal, where I work, well, actually I'm part of VMware now, but we are formerly part of Pivotal. Pivotal, Netflix, Lightbend, NAE TypeSafe, and the Eclipse Foundation, all these different organizations got together and we extracted out 4 common ground interfaces. These are called the reactive streams specification. These 4 types are super Spartan, but they do serve our purpose as well. They give us a way to say, hey, I've got some data, it's not here right now, but it might be here in the next nanosecond, in the next millisecond, the next hour, the next year, the next week. When is not really specified. It's just asynchronous. We just need to know it'll get here eventually, or maybe it won't. These types are very useful, and they give us the foundations on which we can then layer up. So then different projects, like Project Reactor on the Spring team, right? The Spring team created a project called Reactor. Reactor is an API to deal with these low-level reactive streams types. Is that enough? Can I go to production with Reactor? I wouldn't. Not today, I certainly wouldn't, right? Reactor solves composability, it solves data flow, but it doesn't actually solve the bread and butter use cases that drive our businesses. How do we build services that solve business requirements? How do we stand up HTTP applications and do security and do data access in a way that supports these asynchronous types? That's where we come into, where Spring comes into play. Spring, Framework 5, released in 2017, is the first version to integrate natively the reactive support into the framework. On top of which we have since released Spring Data, Spring Security, Spring Boot, Spring Cloud, etc., and a number of other different technologies that all integrate these reactive types. And that journey, my friend, that journey is what we're going to take today. We're going to walk through the basics and then move up into sort of services. We're going to see what it looks like to build services using these reactive APIs. And of course, to do that, we're going to go to my second favorite place on the internet, after production. Obviously, I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. So we're going to build a brand new application using the latest and greatest versions of Spring Boot because #YOLO. And we're going to create a new service. And you know what? Today, I'm going to use Kotlin. Anybody have a reason not to? Why not? I was thinking about it. I can give you a nice tour of what's coming in Java by walking you through some of the features here in Kotlin. So we're going to see features that look like var, which is just released. We're going to see features that look like Java Records, which is coming. Lots of good stuff there. So we're going to build a service. I have to make some choices here. There's a couple of choices. Obviously, the first choice is the choice of packaging. What type of packaging would you like to use today? Obviously, there's two different choices before you. I encourage you to select the default, which is just .jar. It's much more flexible. It's the most useful version. But then, of course, we have three different choices about which version of Java we'd like to use, what version of the JVM we'd like to use in this case. And here, my friends, there are but 2 out of 3 options that are worth your consideration. One of these is wrong, and I don't want to give it away. I don't want to spoil the plot, but I'm going to give you a little hint. I'm going to give you a little clue about which one is the incorrect version to use, okay? And again, if you figure it out, don't tell anybody else, okay? Let them figure it out for themselves. I don't want to ruin the fun for them, okay? Now, again, if you can figure out which is the wrong version of Java to be using, nod your head. Who's figured it out? Okay, that's the wrong version of Java to be using. It's technically inferior in every way. It has less security, less performance, less features, less syntax, less robustness, less operationalizability. It's just an irrelevant version of Java. It has no place in production today, in 2020, okay? Flying cars? Not quite. Java 8? Definitely not, right? Now, that leaves us with 2 other options. Java 11, which is the current long-term supported version of Java, which is fine, or Java 13. Now, Java 13 is the current supported version of Java, soon to be obviated by Java 14. Now, Java 13 is a nice version, and if I were writing Java code, I would always stick to the latest and greatest version of Java. But since we're using Kotlin, that's actually going to force us down to 11 anyway, so our choice is moot. But keep in mind, Java 11 is an acceptable version of Java, but it's a bit of a coward's refuge, okay? It means that you don't trust your operations to be able to upgrade every 6 months. How hard is it to upgrade Java? Seriously, especially if you're on a cloud platform and you're doing continuous delivery, this should not be an issue. You can conveyor belt yourself to the next version of Java automatically in most cloud platforms. So I wouldn't worry about being scared of the JVM. If you're scared of the JVM, then life is going to be very tough, right? There's a lot more scary things out there. So I'm going to use Java 11 because that's what I'm going to get stuck on anyway. And then I'm going to bring in some other dependencies. But I do want to stress, right? I want to stress that Java 8 is not a good choice. It's technically an inferior choice in all ways that matter. It's also morally an inferior choice. Are you prepared to have that discussion with your children to admit that you're still using Java 8 in production? I don't think you are, friends. I don't think you are. So we're going to go ahead and move up to the latest and greatest. And then we're going to choose some dependencies. I'm going to use RSocket. I'm going to use the reactive web support. I'm going to use R2DBC, which is an abstraction for SQL data access. And then I'm going to use the security. I'm going to use Spring Security, okay? So that gives us a number of different dependencies. Let's go ahead and build our application up. And I'm going to hit generate, and that's going to give us a zip file. Now, there are a number of different things that we could have chosen for our data access layer. You notice that I only chose the R2DBC. Now, when we do data access in the reactive world, we have a number of different data access technologies, but these are not reactive facades on top of existing drivers. They have to be, from the ground up, rewrites of the drivers themselves, asynchronous IO-centric drivers. We can't use a blocking API like JDBC to make this work. Similarly, we can't use the old Spring Data MongoDB because that uses blocking API, so we have to use Spring Data Reactive MongoDB. And so there are a number of different options out there that are reactive drivers that are built atop reactive drivers, and I enumerated some of them here. There's a number of different Spring Data projects right now. We've got Azure Cosmos DB, Google Cloud Firestore and Spanner. We've got Cassandra, MongoDB, Redis, Neo4j, Couchbase, and Elasticsearch. And in addition, we also have R2DBC. R2DBC is abstraction for doing SQL data access from a reactive application. One thing I neglected to choose was a driver. So I'm going to go ahead and hit Postgres. And here you've got this nice feature called Explore, where you can then ask the Spring initializer to just give you the one dependency that you would have added, and you can just paste it in like I did. Okay, so there's our application. There's our build, and we're going to use R2DBC. We're going to talk to Postgres. So I need to specify a R2DBC URL. So R2DBC Postgres localhost orders, all right? And we need to specify a username, orders, and a password, orders. Now, can you all see that font? Who cannot see the font? Should I make it bigger? Okay, make it bigger. Font, goody, font, whoops. How's that? Anybody have trouble with that? I'm happy to make it bigger. Okay, just let me know. Good stuff. So we've got now a connection to an R2DBC data store. Naturally, you shouldn't store this in your inline in your code. You can store it as environment variables, export spring underscore R2DBC underscore password, and that would work just fine. And now what we're going to do is we're going to build an application that writes data to the database. We're going to do so using Kotlin. Now this isn't all too different from Java. It's just less lines of code. I don't need to bring in Lombok. Okay, so what I want to do is I want to build an application that writes data to a database. And in particular, we're going to write an entity called a reservation. And this reservation is going to have a primary key, and it's going to have a name like this. So val ID, and this will be an ID. Okay, and that's it. That's my basic object. It's like a record in Java. This data class syntax means that it's going to create a Java POJO that has getters, setters, toString equals hashcode, etc. It's just a one-liner. Makes it very simple to move on. What I want to do then is to handle the persistence of those records, right? So I'm going to create a reactive repository like this. I'm going to extend the reactive CRUD repository. It's going to be an interface that manages instances of reservation whose primary key is of type int. Now, I don't have to do this. It's redundant. It's the same thing. Ditto for this. I don't have to do that. It's just implied. If I don't have a curly bracket, then I'm just defining an empty class, okay? Now, I have this repository, I have this class, and what I want to do is write some sample data to the database. So let's create a few Java config beans, okay? So I'm going to say fun, and I'm going to create an initializer. We're going to write some data to the database here. And this is just going to be a application listener. It's going to listen for a Spring context event called application ready event, right? This is just a callback that we are given when the container starts up, when everything is up and running, and we can use it as a chance to write data to the database. But in order to do my work, I need to inject a pointer to the reservation repository. So there's my repository there, RR, and I'm just going to say I want to create some data. So val names equals flux.just. Now, Flux is a reactive stream type. Actually, it's a type from Reactor. Flux is a thing that describes one or more values. It's an asynchronous thing. It's based on the other reactive stream types. And you can see some of those reactive streams types here in this interface. You can see that we've got publisher. Publisher comes from reactive streams. It's a thing that publishes data out of band to a subscriber. The subscriber then consumes the data in the onNext method of the subscriber. When the subscriber first connects, it's given a subscription. The subscription is what the subscriber uses to control the flow of data, to say, hey, I want more data, to request X more records. This is very useful because it means that your services are now in control of the rate of consumption. This is flow control or back pressure, and it's critical to building fundamentally robust services. So we have these very, very simple types. We've got subscription, publishers, and subscriber, and there's a fourth one called a processor, okay? A processor is a thing that is both a subscriber and a publisher. Now, these types are the foundations. They are from the reactive stream specification. And we have two specializations from Project Reactor, the first of which is, as I just said, Flux. Flux produces 0 or more values. And we can use this static initializer to write some data to the database. So Dr. Sire, we've got Cornelia, we've got Madura, we've got Violetta, we've got... what am I doing? Stefan. Okay. We've got Ria, we've got Josh. I'm Josh, nice to meet you. We've got just a lot of good people on the Spring team. I'm just getting some random names there. And now what I want to do is take each one of those names and write them to the database. So I'm going to say map each one into a new reservation, like this, passing in null for the ID, and then passing in the lambda parameter. So in Kotlin, there's a parameter called it. I could do this, but I could also just rely on the implicit parameter called it. Okay? Now notice that the Kotlin compiler is complaining about null. That means that that means that the compiler thinks this is never going to be null, and here I am passing in null. In order to make it nullable, I need to say question mark. That means nullable. So okay, so now I've got some data, and I want to save each one of those records into the database. So I'm going to say rr.save it. Okay? This pipeline, if you will, this whole pipeline is fairly straightforward, but I haven't actually done anything yet, right? If I were to run this code, I would see nothing reflected in the output in the database. In order to actually see anything running, you need to subscribe to the results. So we can actually subscribe to the database and to the writes, and then write out the results there. The thing is, this is a long pipeline, and I want to make sure that I don't get redundant data calls in the database, no redundant records. So actually, I'm going to say this is a pipeline called write, and I want to actually do some things first. I'm going to say rr.delete all, then many write, then many rr.find all, and then finally I want to subscribe. So what I've done is I've taken these pipelines. This pipeline is one pipeline. Each stage, each step in that pipeline could be asynchronous. We don't know on what thread each stage is going to execute. We don't have to worry about that. Ditto for this pipeline down here. I'm deleting, then I'm writing, and then I'm finding all. The action's going to happen on different threads, but because we're using these operators, we get deterministic behavior. We are guaranteed that what I put in then many happens after everything that is happening in write is finished, right? So one thing happens before the other. This gives you the ability to say, I know that this will happen before that. So now we're doing things that are fundamentally asynchronous and possibly concurrent, and yet we're not dealing with the complexity here. There's no phasers, no threads, no semaphores, no countdown latches, no cyclic barriers, no executors, no runnables, none of that stuff. Remember, there's only one person in the world that truly, truly understands how to write multi-threaded Java code, and it's not you. That's the important bit. It's not you. It doesn't matter who it is. It's not you. So that's my message of hope here, friends. It's actually not a message of hope. It's a message of despair. You're not going to do a good enough job. Don't bother. Let the framework do it for you. It's the only way to sleep at night, right? So we've got now code that we've written to the database. We can run this and see what we get. I'll drink some water. Okay, so we've got a big old exception there. What happened? Available drivers pool. Oh, I put the wrong one. This is the JDBC driver. I want the reactive one. So reactive, web, explore, whatever, and then C when I need R2BC, that's what it was. Explore, please. Okay, there we go. R2BC Postgres. I grabbed the JDBC one. Notice that doesn't do us any good at all. We're using the reactive SQL abstraction, R2BC, instead of the JDBC abstraction, which would just slow us down, okay? So there's this. Let it sync up here again, restart. Okay, there's the data in the database. It worked. We can see that reflected in the output. Each got a unique ID, primary key. It's going to a table in my database, pSQL orders, and I can say select all from reservation, and there we are, okay? There we are, we happy few. Now that worked, of course that worked. Good stuff, we've got data in the database. The next question then, of course, is what about building a web tier? How do I build an HTTP service? And this is a fairly natural thing to do. You can build a functional, first of all, you can build a REST controller, right, like this, and then just build a POJO that actually has a handler methods. But my favorite these days is to use functional reactive style. So I say fun routes equals router, and this is a functional reactive style. And this works fairly similarly in Java, but I'm actually using a Kotlin DSL here. It's a little bit nicer than in Java, so it's just a little bit more succinct. So server response.ok.body, and it's just an endpoint that says whenever I get an HTTP GET to reservations, I want to inject the current reservation repository, rr.findAll, and send a response back. So now if we start this up, what do we get? Now, I I could create a service. This is a thing that a lot of people do. They create the data access tier, the repository, and then they create a service for more granular operations. One of the things you might want to care about in the service tier, if you were to build a service, is how do I do transactions? Well, in Spring Framework 5, we introduced the Reactive Transaction Manager support. So we have a hierarchy that allows you to do reactive transaction demarcation for reactive applications. So you can do it for MongoDB, for Neo4j, and of course for R2DBC, and more are coming soon. This is a really big win because remember, transaction demarcation in traditional applications historically has been based on thread locals. Thread locals no longer work, right? Because remember, the whole point of reactive programming is that the flow of execution is going to jump from one thread to another. And so you can't guarantee that the thread on which you started the transaction is going to be the one on which you finish it. You can't guarantee that that thread local, which is bound to a particular thread, is going to have the same accurate state. So we created a mechanism that allows you to propagate state along the lifetime of a pipeline. That is called the context. And it's actually it's a generic feature that's part of Reactor. You can take advantage of it. But for all the common cases like transaction propagation, like authentication, and authenticated principal propagation, and distributed tracing, all those common cases are all taken care of for you by the framework as well, automatically on the context, using the context, okay? So now, I have an HTTP endpoint. Let's see what that looks like. Localhost 8080/reservations. Nope. Oh, I've got security. I can't believe I'm going to say this, but I'm going to remove security temporarily. Oh dear. Shouldn't remove security. I can feel Spring Security lead Rob Winch's scorn from Kansas City as I do this. So don't do that normally. It's locked down our application, which is what we want normally, but it's going to cause us trouble. So we must get rid of it. Come on. Okay. No? Reservations. Did I not get rid of everything? Security. No, test security. Vintage. Okay. Looks like it. Maybe I just restarted it too quick. It didn't see the class path change. Maven. Reimport. That's awkward. Am I missing something? Maven, reimport. Do you see security in there? Starter security, security messaging, security RSocket, Kotlin's coroutines reactor. Okay. Maven, reimport. I don't know what else I can do to convince this thing, except for, yeah, nuke it. Okay, here we go. Take two. Hopefully this works. Hopefully. Am I missing something obvious though? You see, it says this. It tells me it's not doing what I'm wanting it to do. So we go back to the service, cd service, maven install, stop that. Do you see the generator? Yeah, look. It wants to be secure. It craves security. Let's see, we're missing something obvious. Spring Security Test, could that possibly be confusing IntelliJ? What is going on? We've got goodbye. Maven clean. What? Okay, when in doubt, start that Spring.io. So Kotlin, latest version, Java 11, whatever, RSocket, web, R2DBC, Postgres, okay, explore, copy, oh, whoops, wrong one. I want the latest version here. Explore, Copy. So now, rmrf service.iml, rmrf target, rmrf.idea, idea pom.xml. I'm missing something obvious. And the worst case, we can just actually configure security since that was part of the plan anyway. But I would like to figure out what that is. R2BC Postgres, R2BC, starter RSocket. There is definitely no security in here, right? So I'm going to copy and paste this. Subl. Okay. Paste. Take that over here. Copy. Okay. No security. Enable auto import. Aha. I don't think it was doing that before. Did I not specify reactive web? Oh. Reactive web, please. Okay, take 3. Seems happy. Building. Ah. Sorry? To the what? PLM? POM. Oh yeah, it's this right here, right? How? That's an interesting situation. RSocket. So what happens if we go back to M1? When in doubt, try it out. Okay. Stop and rerun. Re-import. Okay. Terminal. Maven install. No idea. You know what we're going to do? We're just going to go ahead and move on. I'll just actually configure the security. That's fine. So we've got RSocket, R2BC, Postgres, reactive web, and security. We're going to hit explore. That gives us all this. Paste it back in there. Good. Now, in order to use security, we actually have to configure a few concerns. So I've got an HTTP endpoint. I want to be able to talk to it. I need security, right? I assume there's some sort of obvious bug that I'm missing that's making this less than ideal, but we'll figure that out later. It is a milestone after all. And when you deal with security, you have two concerns. One is authentication, and the other one is authorization. And in this talk today, we're going to look at both. Remember, these concerns are related, but they're not the same thing. They're orthogonal. So I've got Spring Security, I've got messaging, I've got Spring Security RSocket, and I've got the Spring Boot Starter for security. So what I want to do is I want to build a simple authentication database. And there's a lot of different ways you could do this, but I'm just going to do something terrible. I'm going to create a hard-coded list of usernames and passwords in my application. So user string pw string equals user dot default password encoder dot username JLong. Sorry, I'm going to use a user there. And actually, let's just for now, to keep things simple, omit the password. So user password pw. Don't ever do that. Roles user dot build. Okay, there's my regular user there, and I'm going to create a user for JLong and another user for rwinch. There we go. So there's my authentication, and already that would be enough. I can now run the application and make a call to it. But what I also want to do usually is care about authorization. So I'm going to care about HTTP authorization, first of all, and I'm going to create a little bean. I'm going to inject a bean called HTTP security, and this is just a thing that tells us what we are allowed to do once we're inside the system. So I'm going to enable HTTP basic. I'll say customizers with default. I'm going to enable an authorized exchange, right? I'm going to say once I am in the system, here I have a spec, right? So auth, I can say path matches to reservations. I want that to be authenticated, and then everything else I want to be allowed to go through. So permit all. Okay. So now I've got simple authentication. I've enabled HTTP basic support, and that's it. I just need to return that back to the framework, and that'll actually configure my authorization. Now let's restart that, and I should be able to, having done that, make a call using curl to that endpoint. So let's try that. Curl -u jlong :pw http localhost 8080/reservations. All right, there we go. Whew, that took forever. Now, there's our data, okay? We've got JSON data in a REST response, and we've got data being stored in a SQL data store. And I can hear you say, who cares, right? Why would I need reactive programming to do what I could have done fairly efficiently with JDBC and servlets yesterday? And the answer is, this is not the sweet spot for reactive programming. Anybody can do this. This is not where we really gain the benefits of reactive programming. All I'm trying to show you here is that fundamentally, you can achieve parity. This is not more complicated than it was before. What we get, though, is a very nice API, and not much more code. It's the same basic idea. It's just that now we're writing data using reactive programming. Where reactive programming really comes into its own is when we're doing things that might otherwise monopolize a thread, things that take a long time. So think about things that require a long-lived session, right? So think about chats or stock tickers or anything that requires liveliness. You know, you want to get the first byte as quick as possible. These things usually have a socket that you keep open and you process data coming from that socket. In the old world, where input streams maps to threads, in this old world, you end up keeping a thread open for the life of that socket. In the new reactive world, we can disconnect that. The number of sockets you have in your machine can be thousands or tens of thousands, whereas the number of threads is really very small. Indeed, in a real inefficient system, you shouldn't have more than the number of cores you have in your machine in threads, right? If you have 4 cores, you should have about 4 threads. That's what we do here. We have a reactor. Reactor is by default a scheduler and a runtime and a thread pool, and it has as many threads as you have cores in the machine, because beyond the number of cores you have in your machine, you don't actually have true concurrency. Remember, if you actually add 1,000 threads to your thread pool, you're not going to get better performance. Quite the contrary. You're going to slow down each individual transaction because now you've added all this unnecessary thrashing for context switching, right? That's going to make your system slower per transaction, and you're not going to be able to handle more transactions. So adding more threads actually can hurt you beyond the number of cores you've got. In a reactive system, by default, we've got as many threads as we have cores. You should understand from that, though, that each thread is very important. You cannot afford to monopolize that thread. If you monopolize it, nobody else in the system can use it. So we have a Java agent called block count, and this is it right here. This is a thing that you can add to your application class path. It's a project that we created, and whenever you do anything silly, like blocking a thread, it throws an exception. Okay? It'll help you ferret out any unnatural blocking of threads. You can create a separate thread pool and isolate those blocking interactions in that thread pool if you like. But the point of this Java agent is to help you catch things where you shouldn't be doing blocking interactions, okay? So we've got that. I've got a simple HTTP endpoint. What's a good thing I can demonstrate that is asynchronous? Well, what about something that produces an infinite stream of values? So I'm going to create a greeting service, okay? Greeting service. And this greeting service is going to produce an infinite stream, greet, and it's going to be a request. Given a greetings request, I'll produce an infinite stream of greetings responses. So let's say data class greetings request, val, and the val is going to be a name here. I'm just going to greet somebody like a hello world string. And I'll have a greetings response that will have a message. Okay, so message. There we are. There's my 2 data types. So I'm going to have, given a greetings request, I'm going to have an infinite stream of data. So I'll say create a new stream, and it's going to be a generator. So I'm going to say greetings response. Hello. Hello. Request dot name at instant dot now. Okay. And there we go. There's my infinite stream. I want to stagger the results a little bit. I'm going to introduce a little offset there. I'm going to delay it a little bit. That way it won't scroll off the side of the screen. So I can use the fact that Reactor is behind the scenes both a thread pool and a clock. I can use that here to introduce an arbitrary delay. So this is a thing that's going to produce an infinite stream of values. If I wanted to serve that back up to my client, I could use WebSockets, right? And that's pretty straightforward. And that would actually work. In between the raindrops, for each new WebSocket message, I would not block. I could demonstrate doing WebSockets, but what I really wanted to talk to you about, as we kind of look towards the future here, is something called RSocket. Now, RSocket is a brand new protocol. It was created by engineers who came from Netflix and who work at Facebook, and it's designed with operations in mind. It's a protocol that gets past all the limitations of HTTP, the considerable limitations of HTTP. RSocket is a from the ground up reactive protocol. It is on the wire. It supports the Reactive Streams API. It actually supports this notion of back pressure on the wire. It is a stateful connection. It is a stateful protocol. So when a client connects to a node, when one node connects to another, they create a connection, that connection stays open. So a lot of the slowness that we perceive when we do HTTP is because of the constant network connects and disconnects and all that stuff. Setting up all that infrastructure each time, that ACK and all that stuff and teardown is very expensive. It's slow. It's also a multiplexed protocol. So unlike gRPC, which is pipelined, but it's not multiplexed. Unlike gRPC, you can handle multiple transactions at the same time with a single connection. So RSocket is bidirectional. Any side, once they're connected, can send data to the other side at any rate, at any time that they want. It allows me to build truly reactive applications, and it's got operations in mind. Because it was built by people trying to operationalize small websites like Netflix and Facebook, because it was built by people like them, it has operation use cases in mind. How many of you have used the Spring Boot actuator? The Spring Boot actuator are a set of HTTP endpoints that are hung off the side of the application. They've been in Spring Boot since 0.4, right? The very first versions of it had the actuator. The actuators give you HTTP endpoints like /health, /metrics, /whatever. These endpoints articulate the state of the service, but they're by no means a standard. There's nothing in HTTP that says you must have a /health endpoint for a service to be a valid HTTP endpoint. That's just a convention that we as a community have all agreed upon. What if the protocol itself had that in? What if there was an official way to say, hey, service, how healthy are you? Can you handle this request I'm giving you? And if not, to move on, right? So now I've got back pressure, that is to say the consumer can push back on the producer, but also the producer can now push back on the consumer, right? The producer can say, hey, I'm too busy, bother somebody else, right? So this is all in the protocol. It's a very natural thing to want to do. Because it's binary, it's also payload agnostic. You don't have to base 64 binary data like you do with HTTP. It doesn't have to be Google Protocol Bus like gRPC. So it's got some really compelling features. When they built the protocol, they built a number of different client libraries. There's client libraries in C++, in JavaScript, and of course in Java. The Java client for RSocket was built on Reactor, right? So if you're ever using Facebook or whatever, you're dealing with code that in some places is using Reactor. Now, because it's built in Reactor, it's trivial for us to implement, but we went a step further and made it even more trivial. So what I'm going to do is I'm going to take this service that I just built and turn it into an RSocket controller, okay? Message mapping, greetings, okay? And there we go. Now it's an RSocket service. Actually, what I'm going to do is I'm going to introduce security here as well. So we're going to delegate to this other endpoint. And the way I'm going to do is I'm actually going to call the other greetings endpoint by getting the currently authenticated user, so reactive security context holder dot get context dot map it dot authentication dot name dot map greetings request, okay, it dot flat map greet. Okay, so I'm going to call greet passing in it. Okay, and there's the entire pipeline. Oh, actually, I don't need this. I can just get rid of that. Okay. And what I've done here is I've taken a mono. I need to convert it into a reactive stream. So there we go. Now I have a RSocket endpoint. I'm assuming that there's a currently authenticated user in the context somewhere. I'm going to access it through the static lookup. I can do it. I can also inject it. And I'm going to turn that currently authenticated user, and I'm going to greet that user. So if it's JLong, as it was up before, then I'll get hello JLong in an infinite stream. But of course, in order for that to work, I need to set up RSocket authentication. So fun, RSocket authorization. And here, I'm going to use RSocket security. I'm going to say rs.build, rs.simple authentication. Okay, I'm going to use the defaults for simple authentication. You can also do JOT or JWT authentication with RSocket in Spring Security. And then we're going to say authorize exchange. So authorize payload auth. Okay, and we say auth dot any exchange I'm going to allow to go through, but I want this endpoint routes to be locked down. So greetings dot authenticated. Is this looking familiar? Does this look like what we have in HTTP? I think it does. I think that's very, very convenient. Your knowledge of Spring Security serves you in both cases. So now we've got this application. Let's restart it. And now I want to build a client to talk to that application. I'm going to go back to start.spring.io. I'll build a client. And this time, of course, I'm going to be using Kotlin. And we are going to use RSocket. We're going to use security. And we're going to use reactive web. Okay, and that's it. We're going to hit generate. That'll give us a zip file. And we're just going to write a simple client that talks to both the HTTP and the RSocket endpoint. So UAO client.zip. And in the client, we're going to define an object that we can use to talk to that service. So bean fun HTTP client will be, I'm going to use the web client builder, web client.builder, and it'll just say WCB dot build, okay? And I'm going to also use the RSocket requester, RCB, RSocket requester.builder equals RCB.build, connect TCP, that is. So I'm going to connect to localhost, port 8888.block. And when I say 8888, I actually want to start up an RSocket service on the server side. So I'm going to say run it on port 8888. Now, there's my basic configuration, but you recall I have security installed in both of those things, so I need to actually care about security. So let's do that. Private val username, user equals JLong, private val PW equals PW. I'm going to create a filter for the HTTP client, exchange filter function, dot basic authentication, this dot user, this dot PW. I'm going to create a metadata install equals equals username and password metadata, this dot user, this dot PW. And finally, I'm going to create a MIME type. So well-known MIME type dot application authorization. Sorry, MIME type utils dot parse MIME type dot, and then we want simple message RSocket. Oh no, not a Maven build problem again. Copy that, latest version. Okay. Authorization, simple please. Am I missing something? That's not it. String. So good thing we have the code just to make sure I'm not losing my mind. Revolution. Okay. T client client pom.xml client.kt. Okay. And that client is this one, message RSocket authentication. Message RSocket. Is this a joke? Maven, re-import right now. Come on. Cotton client pom.xml raw. Okay. pom.xml paste. Maven re-import, please work. Okay, finally, so there's that. So we've got now the things that we need to be able to set up the HTTP configuration. It's a filter, EFF, okay? And for the RSocket stuff, we can do the connection authentication either when the connection is first established, since it's stateful, like this, this dot metadata, this dot MIME type, right? Or we can do it per request, and that's what we could do as well if you're sharing the connection, which is very typical in a web application. So now that we've done that, let's actually use both of these clients very quickly here. So RSocket, RSocket requester equals application listener, application ready event, And all we're going to do is we're going to log out some data. So we're going to say wc.get.uri http localhost 8080/reservations. And now I need to get the data and turn the JSON data that's coming back from my HTTP service and turn it into a Kotlin object. So I'm going to do something terrible, something that you should never ever do, ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So here's this, paste, and where's my greetings types? Here we are, paste. Good stuff. So we've got now the details on the client side, so we can map the JSON and the RSocket data to the types that come back. We're going to say retrieve the data, turn it into a stream of reservations, and then we're going to subscribe to the results. Okay? Here we are, print line, reservation, it. And now we're going to do the same thing for RSocket. We're going to say rs.route is greetings. And we're going to take the data that comes in. We don't have any data that we're going to send in, so we're expecting the body, the data that comes back is going to be greetings response. Okay. And then for each record that comes back, we're going to print line response. Okay. It. And that's it. That's the entire interaction with both RSocket and HTTP. Let's see what that gives us. Oh, I need to do one more thing. Bean fun customizer equals RSocket strategies rs.encoders simple RSocket socket payload acceptor come on. We're going to go to github.com. Okay. Oh my goodness. Client.kt, please. And we're missing one bean, which is this thing here. Got that. Come on. Good. There's this. That's the client side. On the server side, do anything else? Service.kt. I'm worried that we have one more thing missing. Authentication. Security. Looks like that's it. Okay, so did it work? There's this. Oh, port 0. Application.properties. Server.port equals 0. Just random port. Run it again. Oh dear. Come on. Restart. Go, go, go. Access denied. Oh, this is such a bummer. Well, I'm almost going to give up. Here. Active Revolution. Service.kt. We want something obvious. Encoder, where is that? Is it the?
You had a different password on the client and server.
I did? Client JLong and PW?
Here's another one in the service.
Wait, here's the service. JLong rwinch, and the password's PW. And what I'm missing is I think I'm missing a. There's the encoder, but there's actually, that's it. What's the deal? So, set up metadata. What about in the call itself, just to make sure? Retrieve the data. Metadata is this. Get rid of that. And that. I mean, what could go? I'm making a call to the greetings endpoint. sending in the metadata. Connection closed prematurely. Well, okay, try out the code. You'll find that it's mostly the same. I appreciate your time, friends. Hopefully you got something out of it. This is a brand new demo. You can see that it failed. Thank you so much for your time. Have a good day.